I tried the FreeCAD 1.0 assembly and created a video to go through all the functions of the Assembly Workbench. I thought the new Assembly Workbench was similar to A2+ but with some new functions and it won't be much different. However, after I finished the first video, I found the new assembly would be much more than I thought. So I tried to make few assemblies by the gear joint. In this video, I have created worm gear assembly, bevel gear coupling, kitchen mixer mechanism and planetary gears. For the kitchen mixer and the planetary gears, the challenge is to move the spur gear inside the ring gear and spin the spur gear. But actually when I put all the components together, it seems much easier. However, when I created a gear joint for two components rotating about the same axis, it collapsed. Anyway, let me start and see what I got. This video is to create worm gear assembly. The gear joint works also when the axes of rotation are perpendicular. Create a new file. In the Assembly Workbench, create the assembly file. Insert component. In the window, click Open File. Insert the box. Select the box and it will ask you if you want to ground the item. Click Yes for now. Because at least one item must be fixed in the assembly. We can always delete the lock for the item and fix another component instead. Insert item and open file and go the directory I store the parts. Select the gear and worm files. Select these items again within Insert Components window. Click the component and we can show the transform tool, rotate the parts as needed. The pitch diameter of the worm is 50 mm and the 100 mm for the gear. The mounting distance is the sum of their radius, that is 75 mm. So the center-to-center distance of the mounting holes is 75 mm. Select the round surface at the gear and the round surface at the box, create revolute joint. As the thickness of the box is same as the depth of the shaft at that particular section, the gear will seat right at the hole. Select the circular edge at the worm and the hole at the box, create revolute joint. Adjust the offset so the worm is roughly at the middle of the box. We can rotate the gear freely. So rotate the gear to mesh the worm. Once the gear joint is create, rotate the gear will rotate the worm too. Select the circle edge of the worm and circular edge of the gear, create gear joint. Radius 1 is for the first item selected and radius 2 is for the second item. In fact it is to create the gear ratio. The worm is single start so consider it has 1 tooth and the gear has 20 teeth. The rotation direction may or may correct and it may depend on what circular edge is selected. Anyway try it first, if it is wrong, we can adjust it later. The gear joint is set up successfully and speed of the worm is 20 times of the gear. This video is to create bevel gear coupling at 60 degree. We'll see if this will work or not with the gear joint. Create a new file. In the Assembly Workbench, create the assembly file. Insert component. In the window, click Open File. Open the file Be Gear Parts, which contains bodies of parts in one file. Open the file Bevel Sketch 2. Insert the sketch which has two lines at right angle. Insert the sketch and ground this item. Show the sketch as I hide it when I create the file. The length of the line is double the length of the mounting distance. When I attach a bevel gear to the line, the circular edge of the gear will be at the center of the line. Or I can use the line with same length as the mounting distance and adjust the position after I insert it. Insert components, select the gear and the pinion. Select the circular edge of the gear as indicated, it is where I define the mounting distance. Select the line and create evolute joint. Select the circular edge as indicated for the pinion and the line, create evolute joint. Now gear and pinion are placed according to the mounting distance, but they don't mesh. We'll deal it later. Insert the sketch with 2 lines again. Move the second sketch away from the first one. Select these 2 sketches and create fixed joint. Two sketches are overlapped now. Show advanced offset and change the angle to 120 degree. You can see the second sketch rotated 120 degree, or in other words it is 60 degree from the first gear. Insert component. And select the gear. Rotate and move the gear. Select the circular edge as indicated and the line. Create revolute joint. The first gear do not mesh with the pinion. We can rotate either the gear or the pinion to mesh them. Or I can rotate one of them by the exact angle. Open the second revolute joint. Show advanced offset and open offset 1. The gear and pinion overlap by 1 tooth, rotate it by 9 degree would work. Enter 9 degree. And it is good. Now let me fix the second pair. They overlap by 2/3 of a tooth. So turn it by 6 degree should work. Or I can manually rotate it to mesh the gears. Open the third revolute joint. Show advanced offset and open offset 1. Adjust the angle to 6 degree. It is fine. Insert components. Insert the U1 bracket. Hide the first gear so I can see the line. Select the circular edge of the bracket and the line. Create fixed joint. Show the gear. Open the fixed joint. Adjust the distance at offset so the bracket seats at the correct position. Hide the second gear. Insert U2 bracket. Rotate and move the bracket. Select the circular edge of the bracket and the line. Create fixed joint. Show the gear. Open the fixed joint. Adjust the distance at offset so the bracket seats at the correct position. Hide the sketches. Select the circular edge of the first gear and the circular edge of the pinion. Create gear joint. Gear ratio is 20:20. For this joint, any circular edge would be fine as it is to create a relationship between two components. It doesn't involve the distance as for mounting the gears. Do the same for the second pair of bevel gear. Save the file. When I test the rotation, the direction can be wrong. I can find out the actual direction of the current setting and see what to change. Then close the file and reopen it to make adjustments so I don't need to mesh the gear again. Select the first gear and rotate it. I am lucky that all the directions are good. In case I need to change the direction, open the first gear joint and change the distance to minus. If the third gear needs to be adjusted, open the second gear joint and change the distance to minus. The bevel gear coupling is finished. This video is to create part of the mechanism for kitchen mixer. The hook with a small spur gear rotates inside a ring gear. Let me see how to make it work. Create a new file. In the Assembly Workbench, create the assembly file. Insert component. In the window, click Open File. Open the file ring. Click Yes to ground the ring gear. You can see the red lock indicating the ring is fixed. Insert component. Open file. Open the gear parts file. Double-click to get the transform tool. Rotate and move it. Select the bottom circular edge of the shaft at the gear and the bottom circular edge of the ring. Create revolute joint. Adjust offset to 45 mm. The gear rotates and move the arm fixed to the gear. The arm will drive the hook around inside the ring gear. Insert components. Open file of the hook. Select the inside round surface of the bar and the round surface of the shaft at the hook. The length of these two sections are the same and the hook will seat right into the bar. Create revolute joint. Rotate the spur gear to mesh it with the ring before I create the gear joint. Select a circular edge at the spur gear and a circular edge of the ring. Gear joint can be created even the ring is stationary. Create gear joint. The spur gear has 20 teeth and the ring has 60 teeth. Save the file before I test the rotation. The direction is wrong. Close the file and discard any changes. Open the file again and the gears still mesh. Open the gear joint. Change distance from 20 to -20. Or we can change distance to from 60 to -. Either way is fine. The reverse rotation function in the gear joint seams has no effect on the rotation, that is why I change the sign of the distance instead. Activate the assembly first. Move the arm to rotate the assembly. It looks good. The assembly is finished. This video is to create planetary gears with the ring gear fixed. Create a new file. In the Assembly Workbench, create assembly file. Insert component, open file. Open the file for the ring. Click Yes to ground the ring. Insert component. Open the carrier file. Select the circular edge of the carrier and the bottom edge of the ring. Create revolute joint. Offset -3 mm. The carrier rotates about the center of the ring. Insert component, open file. Select the file Planet. Insert it 3 times. Select the hole at the gear and the top circular edge at the carrier. Create revolute joint. Repeat the process for other 2 gears. Now the carrier rotates and move the gears, but they don't spin. Rotate the spur gears to mesh with the ring gear. Select the hole at the spur gear and the edge of the ring. Create gear joint. Spur gear has 18 teeth, and the ring has 54 teeth. Do the same for other 2 gears. Save the file before test the direction. Rotate the carrier and the direction is wrong. Close the file without saving it. Reopen the file. Go to each gear joint and change the distance from 18 to -18. Activate the assembly. Try it again, the direction is okay now. The last step is to insert the sun gear. Insert component, open file. Open the sun gear file. Select the circular edge at the sun gear and the top edge of the ring gear. Create revolute joint. Rotate the sun gear to mesh with the planet gear. This time save the file before creating the gear joint. Usually, I will create a joint between the carrier and the sun gear. Select the circular edge of the sun gear and the circular edge of the carrier. Create gear joint. The speed ratio of the sun to the carrier is 4:1. The ratio for this field is reversed, so enter 10 and 40. Rotate the carrier to test the joint, but it collapses. All the spur gears go to the center. Seems like gear joint for two components rotating at the same axis may cause problems. So, I just closed the file without saving it. Reopen the file. Select the hole at the spur gear and the circular edge at the sun gear. Create gear joint. Number of teeth for both gears are 18. Rotate the carrier to test it. Everything looks good. If you find this interesting and informative, please subscribe and give it a like. Thank you for watching.